Next, let us talk about the requirements for the design of the water reticulation systems as given in the guideline. The guideline is for the case of the Sarawak state. Specifically, it is meant for the water supply agency of Laku Management Sdn Bhd and Cebu Water Board. Most of the requirements are similar for the two water supply agencies, except there are minor differences. The details are given in the guideline here, which is summarized in these slides. The first column here refers to the Laku Management Sdn Bhd, and the second column here refers to the Cebu Water Board. There are common requirements, whereas some are specifically designated to the Cebu Water Board and some are specifically designated to the Laku Management Sdn Bhd. We shall go through the requirements one by one. In general, the water mains needs to be placed at least 1 meter away from any other utilities. For Cebu Water Board, the water mains needs to be placed underneath and at the middle of the concrete path. Second, if it involves sewerage pipe, they are not supposed to be put together. Sewerage pipe needs to be put on the opposite side of the road. Next, the water mains with fire hydrant will require a minimum size of 150 mm nominal diameter. Let's say, taking this project as an example, this will be the water mains. Along the water mains, there will be fire hydrants. As the water mains is to be connected with the fire hydrant, you will expect that the water mains here are supposed to be in the size of a minimum 150 mm nominal diameter. In another word, 150 mm is the minimum size. You may have bigger size, but it cannot be smaller than 150 mm. The guideline allows for the sub-main. This is the sub-main here, which is connected to the mains at 2 points as a branch from the mains system. According to the guideline, smaller size may be adopted for the sub-mains. It can be 63 mm outer diameter or 90 mm outer diameter or bigger size. Normally, the sub-mains is provided at the opposite side of the mains, such as this. The guideline allows for the sub-mains for the developments of 4 or more units of buildings, which in the case of the Cebu Water Board, it will be 10 units, as indicated here. You may determine the size of the sub-mains using the network analysis. Make sure the pressure is sufficient. Now, in the case of the Cebu Water Board, no 90 mm size is used due to the maintenance reasons. In another word, Cebu Water Board only allowed for the sub-mains with the size of more than 63 mm outer diameter, and 90 mm outer diameter is not to be used. While dealing with the sub-mains here, it is stated that extra road crossing shall be provided for 20 units or more, with a rate of 1 crossing per 10 units of houses. What does it mean? Taking this as an example, you will need sub-mains here. Since that there is no existing mains here, and then you will need to calculate the numbers of units here. which in this case 12 units in total. This is less than 20 units. That means you do not need to provide extra road crossing. This is the road crossing. Now, if you find this very hard to understand, you can always imagine this. The idea here is to have one crossing per 10 units of houses. In this case, you have already 2 crossings for 12 houses. You can provide an additional crossing here, but this is not required, since the numbers of the unit here is not more than 20. Let's say now the total numbers of unit here is 20. Then you will require an additional crossing here. So 10 units, another 10 units are serviced by a total of 3 crossings. Let's say you have more units along the way. Then you provide additional crossing every 10 units of building. Why do you need to do that? I believe that it is to ensure the relevant units can still be supplied with water in case of any of the crossing unable to function. Next is about the size of the segments, which is applicable to Laku. If the numbers of units is less than 10, you may use the pipe size of 63 mm. If it is more than 10 units but less than 25 units, you will require 90 mm mans. Now, if you have more than 25 units, you will require another set of 90 mm mans. It is stated that the switch valve fire hydrant shall be installed at the end of the pipeline. The main purpose of the fire hydrant is to supply water for firefighting. It is also used for scoring of the pipeline. In another word, the fire hydrant can be used to flush out the sedimentations trapped at the end of the pipeline. That's why they require the fire hydrants to be put at the end of the pipeline, where the sedimentations usually occurs. It is also stated that the dead ends of the mains shall be avoided. If possible, loop the piping system in order to minimize the dead ends. Taking this as an example. Now, if this area is also under the same project development, it is recommended that instead of having the dead ends here, looping should be done. Just that unfortunately for this particular case, this is not a part of the development. That means there is no choice. You will need a dead end here. Next is about the pipe crossing the culverts. For pipe crossing the culvert, you will have to cross over the culvert and over the wing wall whenever possible. This is the wing wall, and this is an example of the culvert. It is not recommended that the pipes crossing underneath the culvert. Later, there may be issues with the maintenance. Let's say you have an incoming pipe here. You can either choose crossing the culvert or crossing the wing wall. Both methods will have to go above the wing wall or the culvert. Since there will be change of the elevations of the piping system, let's say after the culvert, it will go back to the original elevations. Then this will be the regions where the air bubbles can trap. In this case, you will require the air valve. What you see here, the air valve are normally placed at the highest locations of the piping system. so that it can effectively release the air bubble from the piping system. Now, if the pipe is crossing drains, it shall be crossing over the drain or flush with the top of the drain. The purpose here is not to obstruct the flow of the water in the drain. For example, this. You have concrete drains here. Now you will need pipe crossing the drain. You have two options here. One is having the pipe crossing on top of the drain, or you have the pipe flush to the top level of the drain. This is what it means by the statement here. The purpose here is to prevent the pipe to obstruct the flow of water in the drain. That is one minor issue. Now, in the case that the drain brings along some waste, branches, leaves, and any other floating item, having the pipe crossing and disturbing the flow will gather the waste together, and eventually those will be accumulated near the pipes, and this may induce unnecessary pressures or damage to the pipe. Now, for the pipe crossing over the drain should not obstruct the footpath. That can cause safety hazard to the pedestrians and the road users. For the drain less than 750 mm deep and not more than 1 meter wide, that means these are the small drain, the pipe may be installed under the drain. However, this is provided that the drain is designed not to settle. That means there is proper foundation system preventing the settlements of the drain. Now, in the case that you are providing the pipes underneath the drain, you will need a 150 mm layers of compacted sand between the drain bottom and the crown of the pipe. So it should look something like this. For a small drain here, you can choose to have your pipe passing through the drain underneath it. This is provided that you can guarantee that the drain does not undergo any settlement, as this could have damaged the pipe. Now, if you are having the pipe passing underneath the drain, you will need a layer of at least 150 mm compacted sand between the pipe and the drain. This is conditional to the size of the drain, less than 0.75 meter depth and less than 1 meter width. If the drain size is larger than this, you will have to cross your pipe over the drain or flush with the top level of the drain. Pipe supports needs to be provided for the pipe install unless you can prove otherwise, or you can give a 5 years guarantee that there won't be any issues with the settlements. This is requirement by the Cebu Water Board. The main reason for this is due to the soil conditions of the Cebu region, where there are pit soil, which is organic soil, usually will have issue with the settlement. Therefore, the Cebu Water Board required the pipe to be properly supported in order to prevent settlements of the pipe that may ultimately lead to the stress and leakage of the pipes, and then there will be issues with the maintenance later.